So if I was to remember when we did this circle, right? We had these points here, here, and here. Do you remember what sine, cosine, and tangent equals? Y over x. So if you replaced y with sine and x with cosine, what would tangent equal? If you replace this y with sine, because those are equal, aren't they? And this x with cosine, exactly. Tan equals sine over cosine. Secant is just the reciprocal of cosine. When you take the reciprocal of something, what do? Right, flip it. So this is like secant over 1, so that would be 1 over cosine x. Right? When you take the reciprocal, you just put it over 1, or 1 over it. Cosecant is just the reciprocal of sine, and then cotangent is the reciprocal of tangent. So you just flip it, like Anton said. So you'd get cosine over sine. So this is the first identity we're going to look at today. It's sine squared x plus cosine squared x equals 1. And we're just going to look at the different forms that you might see it in by either subtracting or adding. Okay? And what we're going to use these for is to prove that two things are equal. Okay? And this is going to make it a lot simpler for you. So essentially what this is showing you is that here, if we subtract sine x squared from both sides, you're going to get a different form of the identity. So if you start with sine squared x plus cosine squared x equals 1, and you subtract sine squared x from both sides, you'd get cosine squared x equals 1 minus sine squared x. And that's going to be your simplified identity. So ultimately what that means is if you see cosine squared x in a problem, you could replace it with 1 minus sine squared x. Or likewise, if you saw 1 minus sine squared x in a problem, you could replace it with cosine squared x. All right? So ultimately what we're going to be trying to do is interchange these different identities to get the simplest answer. So again, if we subtract cosine squared x, you would get that sine squared x equals 1 minus cosine squared x. So these are the first two identities. And these are all, again, just variations of this one. Right? These are all just variations of this one. So what would happen, remember, we're still going from sine squared x plus cosine squared x equals 1. What would happen if we divided sine squared x? So sine squared x over sine squared x plus cosine squared x over sine squared x equals 1 over sine squared x. Looking back to the warm-up, well, first of all, what would sine squared x over sine squared x be? We have 1. Okay. What was cosine over sine from the warm-up? Cotangent, right. So 1 plus cotangent squared x. And what's 1 over sine going to be? Cosecant, right. Cosecant squared x. So now we can form new identities from this. And again, it's all the same. All we did was alter it by dividing by sine squared theta, or sine squared x. All right. So now from this, we can subtract 1. So if you had 1 plus cotangent squared x equals cosecant squared x, and you subtract 1, you'd get that cotangent squared x equals cosecant squared x minus 1. So again, If you saw something like cosecant squared x minus 1 in a problem, you could replace it with cotangent squared x. And if we went from 1 plus, and we subtract cotangent, you would get 1 equals cosecant squared x minus cotangent squared x. So again, if you could take something like this, which is not that pretty, and replace it with a 1, that would make your problem much simpler. So just like we divided by sine squared x, we can also divide by cosine squared x. So we can divide this entire thing by cosine squared x. Does anyone remember what sine squared over cosine squared was? Right, tangent squared. So we have tangent squared x. Cosine squared over cosine squared is just 1. And 1 over cosine squared would be what? Secant. Excellent. So now we have this identity as well that we can interchange. So we have tan squared x plus 1 equals secant squared x. We can subtract 1. So you get tan squared x equals secant squared x minus 1. So we have yet another different form. And we can subtract tangent squared x. So you get 1 equals secant squared x minus tangent squared x. So every single one of these is coming somehow from this identity here. Whether it's you either add or subtract there, you divide by sine squared x, you divide by cosine squared x, and then add or subtract. So these are, let's see, 9 of the identities that you're going to be using, as well as the what we did in the warm-up. So these are relationships with negatives. Yeah. I would write this on the back. So if you have sine of a negative angle, that equals negative sine of that angle. Okay? So if the angle is negative, you can bring the negative out front, as well as with cosecant and tangent. Okay? So any of these three, if you have a negative angle, you can simplify that by bringing the negative out front and having a positive angle. Whereas with, a cotangent as well. So this should really be, that would make that more sense if this was over here. So cotangent of negative theta equals negative cotangent theta. Okay? And with cosine and secant, when you take the cosine of a negative angle or the secant of a negative angle, you can just get rid of the negative altogether because it's going to be the same. Because if you take the negative of an angle or the positive, they're both going to be the same sign. Does anyone remember when we grouped these 4 together before and these 2 together? Something to do with graphing? Do you remember what else these have in common? So all of these are odd, and all of these are even. So the odd functions, you bring the negative out front. The even functions, you can just get rid of the negative altogether. Okay? So that's an easy way to remember it, if you know that these are odd and these 2 are even. Or the other thing is just cosine and secant. You can get rid of the negative, and everything else you have to bring it out front. Okay? If you looked at the graph of cosine, India, it doesn't matter if you go in this direction or this direction. The y values are going to be the same. All right, last thing we're going to look at before we get into some problems is these co-function relationships. All right? So for sine, Yeah, you want to write these down on the back. The sine of an angle is equal to the cosine of 90 minus that angle. Okay, so an example of that is like sine 6, sine 30. What's the sine of 30? 1/2. And then what we're saying is that's equal to the cosine of 90 minus 30, which equals the cosine of 60, which is 1/2. All right, so this is going to help. You can substitute cosine of 90 minus theta with sine theta. So with these, what you really need to remember is the pairs, okay? So sine goes with cosine, okay? Cosine theta equals sine 90 minus theta. Same thing, just flip this cosine and sine. And then tangent goes with cotangent, and secant goes with cosecant. So these shouldn't be too difficult for you to remember which one goes with which one. You're not going to have to produce this. You just have to recognize that cosine 90 minus theta is the same as sine. You wouldn't have to go the other way around. All right, so you'd see the same thing with tan 60. Tan 60 is root 3, and cotangent 30 would be root 3 as well. Right? That would take some calculations, but they're going to be the same. All right? So when we're simplifying these trig expressions, you want to first use your formulas, your cofunction relationships, and relationships with negatives anywhere possible. Okay? Then you want to use your Pythagorean relationships, which is your sine x squared plus cosine squared x equals 1. Actually, yeah, I'd go ahead and write this down. Just write it down. I think it'll be helpful. And attempt to rewrite using sine and cosine. There will be some times where it'll be easier to leave it as tangent, but we'll talk about that later. And then we just simplify algebraically. All right, so first we want to use our cofunction and get rid of our cofunction problems and get rid of our negatives. And then we want to go to our Pythagorean identities, which are the 9 on the front of your sheet, and see if we can simplify anything there. And then the last step is just to simplify algebraically. So, first example. All we're trying to do is simplify this as much as we can. So, one of the first steps, we don't see any of the cofunction or negatives here. I don't see anything I could use a Pythagorean identity for. With the Pythagorean identities, there's always going to be squared. Okay, it's always going to be sine squared or cotangent squared, something like that. So then if I can't use any of those, I want to try and put it in terms of sine and cosine. So what does cotangent equal from the warm-up? Cosine over sine. So I have cosine x over sine x times sine x. What would sine x be over? 1. Good. What can I do here? Cross out the signs, and you get cosine x. And that's much simpler. All right. So here, you should recognize that as some sort of identity. Whenever you see the squared, you should automatically think, okay, let me check my identities. But what can I do before I do that even? Right, factor out of 5. When we're simplifying, we have to make sure we still keep it in our problem. So we have secant squared x minus tan squared x. And if you look at your identities, what does that equal? I think that's one of the last ones on the bottom. 1, right. So this entire thing here equals 1. So now we just have 5 times 1, which equals 5. And that's your answer. So this entire thing just equals 5. Look at your identity sheet, and you'll see that this equals 1. Let's look at another one. 1 plus cotangent squared x equals secant squared x. So first things first, I see some squares. Do any of those match up with any of the identities? This right here? So you're telling me that 1 plus cotangent squared x equals cosecant squared x over secant squared x. Okay. So we don't have any more identities there. So that was from the identity sheet. So now, does anyone remember what that second step was? Once we get to where we don't see any more identities, anything else we can simplify, what do we want to do? Right, so now we write as sine and cosine, if we can. So what is cosecant in terms of sine or cosine? So we have 1 over sine squared x over secant squared was 1 over cosine squared x, right? And what do I do when I have a complex fraction? Multiply by the reciprocal. So cosine squared x over 1, cosine squared x over 1. So the denominator cancels, and I'm just left with this. And if I multiply across, I get cosine squared x over sine squared x. And again, going back to the warm-up, what does that equal? Cotangent, right? So we went from something very complex to something very simple. This is one of my favorite things. I think this is really cool. All right, so here we have the negative properties, right? So secant, what can we do with the negative? Right, completely get rid of it. So we have secant x. What about with cosecant? What do we have to do? Make it negative cosecant x. And then, once you're here, what do you think the next step would be? Make it sine and cosine. Excellent. So this would be 1 over cosine x over negative 1 over sine x. Again, you'd multiply by the reciprocal. It doesn't really matter where you put the negative as long as it's in there. It could be with the sine or it could be with the 1. So then you get negative sine x over cosine x, which equals negative tangent x. Excellent. All right, why don't you guys try these? Try this one. I'm sorry. So, cosine negative x, what does that equal? Cosine x. So I have cosine x, secant x over sine x. Right. So cosine secant x is 1 over cosine x. So this is like, so what's going to happen up top? Right. So you get 1 over sine x, which equals cosecant x. Pretty cool. What this in here is cosine x times secant x. So it's cosine x, which is over 1, times 1 over cosine x. So you'd get cosine x over cosine x, which equals 1. All right? Yeah, exactly. Secant is 1 over cosine. All right, last one we're going to look at. Cosine 90 minus x. What does cosine go with? Chaz? Cosine goes with? Nope. Sine. You said it was common sense. Chaz is already famous. I'm getting money for mentioning him. I'm getting a monetary benefit.